Hi everyone and welcome into this new video in which I continue my Windows Privilege Escalation series. The topic of this video will be to analyze some of the most critical registry paths. So we will talk about the registry, which I've already introduced in the sensitive data video on Windows, but this time we will talk about specific registry keys, which are the following one, which I picked, and they represent some of the most critical registry paths. This means that if you are able to overwrite values into this registry path, then you might be able to introduce malicious code to obtain privilege escalation and in general to perform malicious activities on the system. Now, these are not all the sensitive registry paths. These are some of the most important and also simple to explain, but essentially the idea is that you're gonna have all the registry paths, which I will not cover in this video. This video is just to give you an introduction to some of the most critical registry paths. So let's get straight into the topic and talk about registry. Now, I've already discussed what is the Windows registry. Essentially, it is an hierarchical database that is structured with tree-like data structures, and each tree represents a specific registry hive. So we have different registry hives. Specifically, there are 5 main hives, and these are the HK classes root, the HK local machine, the HK users, HK current user, and HK current config. And they have the abbreviation HKCR, LM, U, CU, CC. So the idea is that we have this sort of like big database, so you can sort of think, okay, here we have a bunch of different trees, which is a very common data structure that you will often find when you study computer science. And in each node of this data structure, there could be different values. So here we have attributes that have names and that have values. So in each path, you can have different names with different values. So that's the idea. Now, of course, for each hive, we have a respective file. So for example, you have the config software, config system, config default, and user data system profile. I've already discussed about this in the sensitive data in Windows video, where I show how to extract the data using a Python script. Now, there are many uses for this registry. For example, in the context of malware analysis, the data that is found in this registry is often used for doing threat intelligence. That is, for understanding the activities of malicious software and how the software modifies the system and the environment in which it is running. And this kind of modification can be picked up by analyzing how the registry is accessed. So the idea is that you gain threat intelligence by analyzing data access to the registry, and then you can figure out the indicator of compromise, IOC, which you can then later sell or distribute or share and stuff like that. Now, given that the registry contains a lot of important configuration for the Windows system, there are certain paths that, if misconfigured, could be dangerous. And here, the threat model we have to consider, we have to understand is that, let's say that a malicious attacker is able to modify any of these 4 different registry paths. So they have full control over the attributes and the values found within this path. And the question is, what can an attacker do with this sort of privileges? So in the video, I'm gonna use an administrator account because I did not set the correct privileges, but essentially imagine that you can give to the attacker this kind of permission, and then you can see the result in terms of code execution, privilege escalation, and things of the sort. So assume you have control over this path. Now, the first registry path that I want to talk about is the HKLM system current control set services. So essentially, this belongs to the HKLM, so the local machine configuration, the local machine registry. And why is having access to this path critical in terms of security? Well, because services are a common target for privilege escalation, and this was already discussed in the previous videos of the series, and specifically these 3 videos were mainly targeted on services, Windows services, weak service permissions, and unquoted service path. We also did a video on DLL hijacking. I also did a video on that, so that is also linked to attacks on services, but these are mostly focused on services. Now, but what's the idea? How is, for example, the service configuration linked to this registry key? Well, the idea is that when we configure a new service, the system writes a new key into this registry path with a bunch of information with respect to the service. And among this information, we find the image path attribute. Now, this attribute is used to specify the executable file that is linked to that specific service. This is very similar to the video that I discussed on weak service permission, in which we have the configuration of the service in which there is another property called the bin path. So, essentially, the idea is that by modifying the bin path, actually what we were doing was modifying the underlying image path present in the registry at this specific path, and then here you have to add the name of the service, so like for example name here, and for different services you have different names. So the idea is that when we modify the bin path of a service, we are actually modifying the underlying image path. This means that, for example, if an attacker is able to directly modify the image path to directly access the Windows registry, for example, with the following PowerShell command, the one that I'm highlighting. So notice here, we do set item property, we specify the path, which is the HKLM system, current control set services, and here we find the name of the service, which is simple service. Then we say, okay, I want to modify the attribute called image path with this value, with a different executable. Now, if an attacker does that, essentially, the next time we activate the service, for example, by doing a restart service with the name of the service, we're going to execute the new binary and not the original one. So, by having access to this registry path, an attacker will be able to hijack the execution of each service he has access to. So essentially that's the idea. For example, consider we have a binary called simpleservice.exe and we want to add a new service that executes this binary. So in the path, C users quickemu downloads simpleservice.exe. So here I have the notes for the previous video, from the Windows service video here on the right, this one essentially. So I can simply copy this. Of course, it did not really copy it, so I have to copy it again. So I'm gonna copy this and I'm gonna create the simple service. So now I've created the simple service. Now, let's try to get the item property at this path. So this current control set services simple service. So let's get this path. So of course here I have to do it again. Okay, get item property. Now here we have a bunch of information on this specific service called simple service. Specifically, we have this attribute called the image path with this specific value. It means that when we're gonna start the service, we're gonna execute this binary. Perfect. Now, to actually understand what happens when a malicious actor is able to modify this image path attribute in the registry, let's take a very simple executable, which here I've called here hello.exe, and the source code for this executable is this one. So in this source code, I'm simply gonna create a file in the path C users quickemu downloads test.txt, and I'm gonna write a simple hello world string within the file that I open in write mode. Perfect. It's a very simple thing. I've cross-compiled it with the cross-compiler toolchain and I've put it into the Windows system. So if we execute this, notice what do we get. And I do dir. Notice that we get the test.txt file, and if we check its contents, we see the string hello world with the new line. Perfect. So now we're gonna replace the executable, the simple service, with the hello.exe. So how do we do that? Well, we just open the set item property, and essentially here we set the image path attribute of the path simple service, services, and so on and so forth. With the value, here we just have to put hello.exe. So we do this. So let's just do this. Also here, let's delete the test.txt because we want to delete it. At this point, if we get the property again, notice that now the image path has changed and it is no longer simple service.exe. And now we can start the service with a simple start service name simple service. it's gonna print out an error. But then if we check on the disk here, notice that the test.txt has been created with the content that we expected. So essentially, it means that we are able to execute arbitrary code by triggering the service. This happens because now in the image path attribute, we find this specific executable and no longer the original one. So if we wanted to restore to the original one, here we would have to write simple service.exe. So let's copy it again, simple service.exe. Then I put get item, look at this. And now if I start it, start service name simple service, it's not gonna bother me anymore. Now it's actually gonna properly start it because it is the proper binary and so it is able to just run. And in this case, I will not have code execution. So if I remove the test.txt and I restart the service, here I'm just gonna put simple service as the name. I'm gonna restart it, and here it's no longer it's not gonna create the test.txt file because I do not have longer code execution. And so this was the first registry path that I wanted to cover. And also I want to mention the fact that this attack is similar to the one that we saw before in the weak service permission episode. However, this one is different because we are not directly attacking the configuration of the service, but we are attacking an underneath layer, which is the registry. This is because Windows actually uses the service config is just an upper layer. Underneath, there is the registry. So here, if we have a registry, of course, typically, the registry requires more permissions. However, let's say that your system is misconfigured and you're able to write into this path, then you can totally ignore the service config, you can totally ignore the executable on top, and you can directly go towards the registry. You can directly change that. Specifically, you can change the image path, which is different from the bin path, because the bin path lives at the service configuration level, the image path lives at the registry level. And so this is the first idea. Now the second path is actually very similar, because in the second path we're talking about DLL hijacking. Now, there is a specific registry key which contains a bunch of different DLLs, it contains a list of DLLs, and when this value is set, Windows will load into every user mode application that uses the GUI, and specifically those that use the subsystem for application, the Win32 API, it will load the DLL specified in this registry path. Now, this of course imposes a significant risk for security. This represents a significant risk for security, and this is why, as a result, because simply malware may attempt to use this key in order to inject malicious DLLs into system or processes. I mean, the idea is that if you're able to write here and this thing is enabled, it is used by the system, Windows will load the malicious DLL for you. So you don't even have to worry about how to load it into a single process, because Windows will do it for you by default, by design. And this is why this registry is often disabled. And actually, there is a specific attribute within the path that tells us if this thing is enabled or not. So here, let's make it clear. So here it's HK local machine. So we can abbreviate it with HKLM, as I did previously. Here, technically, the registry path ends in Windows, so we don't have these app init DLLs. Why? Because this app init DLLs actually represents the name of the attribute that contains the list of DLLs. So to make it a little bit better, so this is the actual path. And then here we have two attributes of interest. The first one is load app init underscore DLLs, and the second one is app init DLLs. So the first one tells us if the second one is enabled. The second one contains the actual list of DLLs, so it is the one that represents the security risk. However, it is disabled by default because modern versions of Windows have additional protection to restrict or limit the usage of this particular registry attribute. So what's the idea here? Let's try to understand, for example, if in our system this thing is enabled or not. We can do so with the getItem property. We put the key and the name has to be load app init underscore DLLs. So we copy this and it says 0, it means that it is not enabled. So pretty simple. So that's the idea. We can enable it by writing it 1, we can disable it by writing it 0. By default, most often you will find it disabled because it represents a significant security risk, which unless you really need it, just don't use it. It's much better. Now though, let's say that you want to use it. How do you do that? Well, you can once again use the getItem property and the setItem property command. So if you want to read the value of the app init DLLs, we can simply do getItem property with the path of the registry. And so let's copy it better. And so here we have, essentially it is an empty list, so there's no content here. However, let's say that we want to set it to something. So the value, how do we specify the value? So notice here what we do. Essentially, I'm gonna copy here for better clarity. But the idea is that we have a string. So just let's put text mode. So we have a string, and then we have each path to each DLL, and the different DLLs are separated by semicolon. So we have an entire string. We have the path to the first DLL, a semicolon, the path to the second DLL, a semicolon, and so on and so forth. This is similar to how we specify path in the Linux system, so that's essentially the idea. Of course, we have different separators, but the idea is that we have a bunch of different paths separated by a specific symbol, which in this case is the semicolon. So not much to say here apart from the fact that this of course allows you to do DLL hijacking, which I've talked about this kind of attack in a previous video. So go and watch that video of DLL hijacking. I will put a link into the description. So essentially the idea is that through registry, sort of like we can do attacks that we previously discussed, and this as far as the first two paths are concerned. The first one with services, the second one with DLLs. Now let's go to the third one instead. This one is in Windows current version run. So these keys determine which applications start automatically. So specifically we have the current version run of the HKLM or of the HKCU. Now the difference is that if you are configured with the run in the HKLM, this will affect all users of the system because this hive is for the local machine. So modification to this hive will reflect on all users, while the CU hive is for the current user, so only the user that you are actually logged on as. So the first one affects all users on the system. Programs that are listed there will run at startup for every user who logs in. It requires, of course, administrator privileges to modify because once again it represents a security risk. Now this sort of keys can also be used for red teaming operation. Let's say that you compromise a machine, but you want to extract credentials, you want to extract tokens, you want to extract information from the people who actually use that software. Then you can think of using this kind of keys to achieve persistent over time in your system. So every time the system boots up, you can execute malicious code by modifying this registry key. And of course, you want to modify the HKLM because you want to affect all users of the system. And so these were the run entries for the HKLM and HKCU. We also have the run once path here. Instead of run, it's just run once. And the idea is that they are executed exactly once and then they are removed from the registry. So it means that they actually will not be executed again because their configuration will be removed from the registry. So that's the idea. Now let's test it out. So we have here our file, our hello.exe that creates the test.txt file. So let's try to execute this upon a login. So how do we do that? Well, first of all, let's get the item property hkrun like this. So let's get this item property. Let's get this item property. And what do we have here? We have, for example, this test program that I added this key to do some testing myself. And then we have a bunch of different others. So for example, we have this security health, which executes the security health systray executable. Now let's modify the path of this test program to essentially point to our hello.exe and not test.exe. So we can do this essentially test program, and then at the end, I'm just gonna put hello.exe. So I'm gonna do this set property. So I'm gonna do this, and then I'm gonna copy this. into the system. Now I get item property, and notice, now the test program is set to hello.exe. So now I have no txt file. Let's do a logout and a login. So I'm gonna sign out, and then I'm gonna sign in again. And the idea is that when I will sign in back, so here, I'm gonna put my simple password. When I log in back, I will actually execute that program, which will create the test.txt file within the downloads folder, as we will see. Here it takes some time to start up. I mean, this is Windows, we have to understand it somehow. So let's wait, let's go into the downloads folder of QuickEmo, and essentially let's wait a bit. So let's wait a bit, and notice what happened. While we were waiting, actually, we saw the program execute, and we saw that this file was created. Now, of course, a malicious actor would not simply just pop a file like that, just spawn a file randomly like that. They would execute malicious code that the user cannot see. But that's the idea. So that's the entry point. That's like the persistent method for executing code. Maybe it is not as much useful for privilege escalation because it assumes you already have administrator privileges. However, I still wanted to mention it because it's a very critical registry path, which is useful to know regardless of privilege escalation or not. And so this is for the current version run. If you set the run once, you're going to execute it once, and then at the next boot, you will not execute it again because it was removed from the registry. Now, for the last registry key that I want to talk about is going to be the current conversion win logon. So the win logon registry key is used to configure how Windows interacts with the logon process. Specifically, it's going to define the program to execute upon a login. For example, if we just put the name cmd.exe, if we just write to this registry the name in the attribute shell, so in the attribute shell we write cmd.exe, like first of all, let's try to read the item property of winlogon in general, regardless of the item shell. So we have winlogon, of course we have a lot of different stuff here. For example, we have a default domain, default username and stuff like that, auto restart shell, background, and stuff like that. And then we have a shell, which in this case is explorer.exe, and also we have userinit, which is userinit.exe. Now, and also we have this sci-host.exe. I would say that if you find executable path within the registry, they could be critical, because maybe if you modify them, then you can get code execution. Now, in this case, if we modify this shell, the value of this shell attribute within this path, within the winlogon path, we're going to change the first program that is executed by the system. So how do we do that? Well, for example, we can do a set item with the value cmd.exe. So let's do cmd.exe. And then at this point, we just need to log out once again. So we just to sign out. And the first thing, once again, is to sign in again. So we sign in. And now, and notice at this point, when we log in, we do not get the same explorer.exe that we usually get with the graphical interface. We just spawn a cmd.exe. Now, why is this the case? Because we changed the winlogon registry key. Now, how do we get it back? Well, we can start a PowerShell like this. Then we can increase the privileges with this, with this run as. We're gonna say yes. So this is gonna spawn a PowerShell as a privileged user, essentially. Then let's get the getItem property path. Here, notice that it says cmd.exe. We want to change this shell, and we want to change it to explorer.exe. And then we're going to log out. And to actually log out, the command is log off. So we do log off. We're going to log back in with the user QuickEmo. And now we're going to have our Explorer back, essentially. Now, what's the idea here? Once again, a malicious actor will definitely not change the way the system looks. So it's not like it's going to remove the explorer.exe to just give a shell, because that would be obvious to detect. What a malicious actor is going to do is going to introduce malicious code in the code chain, in the program chain. So maybe you still get your Explorer back. However, he used that registry key to change the program that is executed in order to introduce a step that is malicious. So essentially, this is the idea. Once again, is this linked to privilege escalation? I would say not necessarily, because to change these keys, you already require pretty high privileges. So either the system is misconfigured and somehow we are able to access these keys, or if it's not misconfigured, what this registry key are actually used for is more for persistent than for privilege escalation. I mean, I'm putting in the privilege escalation series because we are reaching the end, but consider these more for persistent methods to like keep executing code on a victim machine that you previously infected. Now, here are some references with respect to Registry Hives. This is a vlog from Google Project Zero. It goes very in depth, and this is also another interesting blog post that goes in depth into the mysteries of the registry. So of course the registry here, I said it is a pretty simple data structure and stuff like that. But actually, of course, in reality, there are a lot of nuisance, there's a lot of complexity that we are not showing here. In here, I just discussed 4 critical registry paths. Of course, there are many more. How do you search for this? You can just document into the documentation, you can just read how it works. And the idea is that once you understand that a potential thing can be used also for malicious reasons, then you know also how to defend better. So once again, not always for privilege escalation, also for persistent. So this is it for this video. I hope it was interesting and see you to the next video.